Hello, everyone. My name is Juan. I'll be walking you through an introductory session on Fusion 360. Fusion 360 is a very powerful CAD application. You will see it being used in many different scenarios, anywhere from engineering to design, just general making, and all kinds of fabrication and rendering. It's quite powerful, but it can be quite confusing at first to encounter it because there's so many things in this interface. So let's walk through it together. And let's start by getting familiar with the interface. So once you've logged on to Fusion, and remember Fusion is completely a cloud-based solution, so you must have internet access to run it unless you decide to go on offline mode. Some things will get disabled. But you have to be logged into your Autodesk account in order to be able to gain access to this screen that you see here. So let's start by navigating a bit through the interface, and the first thing that I want you to notice is this element here where it says change workspace. And once you click on this, you'll get access to different environments here. So you have the design environment, which is where you create most of your designs for solid parts. We also have a generative design workspace where you can interact with the generative design tools from Autodesk. We'll get into those in a later video. You have the render workspace that lets you generate photorealistic renderings of your project. You also have an animation suite to let you do things like exploded views, assemblies, all kinds of other animations in a very rich environment. You also have a simulation workspace where you get to create finite element analysis of the parts that you're generating to see how they perform under stress or heat, etc. You also have a manufacturer workspace where you get to produce things like tool paths for CNC machining, cut sheets for laser cutting or plasma cutting, and also 3D printing, slicing, and also just STL files output from your design. You also have a drawing environment that lets you generate technical drawings from the parts that you just created. So this can be a bit overwhelming to think about, but you can also think about these as almost different applications, different programs within Fusion, and it'll help you break it down a little bit more for you to learn it. So for now, we'll be in the design workspace, and we'll be using basic modeling tools for this initial demo. So we'll just stay here in the design environment. You'll notice that next to that you'll have your toolbar, which will create, will do different things for you. There's a create menu that lets you obviously create basic things like solids and also extruded parts, revolved parts, swept, loft, etc. Then there's the modify tab, which as its name indicates will let you modify parts that already are in the scene. Then you have the Assemble tab, which contains tools for you to create assemblies once you have several parts in the scene. And also there's the Construct tab, which lets you generate different construction geometry like reference planes, reference axes, and we'll get into that in just a minute. We also have the Inspect tab, that lets you, inspect things like measurements, create section analysis, and other analysis tools. There's the Insert tab, which lets you insert things like a decal on top of a surface for rendering, and also a canvas to be able to have a reference image for you to model to. So let's say you have a sketch of something you want to bring in to model, you can actually insert this sketch into the workspace as a reference as well. And we'll touch on that on a later video. So let's generate a simple part. And I have this part here that I have drawn for you. I'll make sure that this part is accessible in the video description, so you can download this PDF file, this image. So if you can, keep it alongside you. I'll have it next to me. You can print it out as reference, and you will create this as your first project. So I'm going to bring this out of the screen, and I'll come back here to Fusion. So everything in Fusion is based upon sketches. So any part that you draw has to be generated from a sketch. You can sketch on a plane of the file, like a top plane or side view, front view. You can also sketch on a existing face of a piece of geometry, and then you will use that to do things like extrusions, etc. But everything's based on a sketch. The first thing that I want you to check is your document setting. So here on this top left side, you'll see the browser. Some people call this the tree. So all of the elements inside your design are going to be found inside this tree. So if I expand this thing called document settings, the first thing that you'll notice when you have an empty file is you have the unit set to millimeters or inches or whatever was your default setting. You can edit this by clicking on this edit button. You can change your unit. For this particular project, we're going to keep this in millimeters. You can also change the default setting for that by going into your preference panel here by clicking on your initials on the top right part of the software and then going into preferences. You can change the default units for your projects. So we're going to go into the Create Sketch tool. There's numerous ways to access tools in Fusion. One way is to come and hunt for stuff here in the top bar by opening up these menus and finding different tools. If you have tools that you use a lot, you can actually go and add these to the top toolbar. Let's say, for example, I tend to use the Loft tool a lot. I can click on the little three dots next to it and say Pin to Toolbar. And the Loft tool is going to get added to that top bar. So if you are the kind of user that likes to use their mouse a lot and you like to go and find these tools in the toolbar, you can create a personalized toolbar for yourself. You can obviously just pop open this menu and come and find the different tools. You can also, for example, type in the letter S, and you can get this search box. So letter S, shortcut S, will open up this search box, and here you can search for any type of tools. If I wanted the Loft tool, from here I can go ahead and find it by typing it in. I'm going to set my origin to visible by clicking here on the little eye. So if it's not visible in your document, make it visible by clicking here on the visibility icon. That is this eye. You can turn things on and off, things like bodies, components, etc., by clicking on their visibility buttons. I'm going to create a new sketch by clicking on the Create Sketch button, and then I'm going to select the base panel. See how you can select different parts of the origin, different planes. So you have the bottom plane and the front and side planes of your view. You can select the bottom plane here to initiate a first sketch. For some of you, depending on your settings, once you click on that panel, the view will rotate and take you to a orthogonal view of that panel. For me, I've set it to do that manually, so I can actually click in this button here in the sketch palette that says Look At, and that'll take me to this top view of the sketch. So once I am inside a sketch, you'll notice your toolbar will change. You'll actually go to the Sketch tab, and all the tools here are now sketch tools as opposed to solids tools. And also another thing that lets you know that you're inside the Create a Sketch section is you get this Finish Sketch button that lets you exit the sketch. So we're going to stay inside the sketch environment and generate the drawing for the base plate. So I'm going to go to Create. I'm going to go to Rectangle and find this tool called a Center Rectangle, and that defines a rectangle based on its center. So I'm going to create this center rectangle. I'm going to snap to the origin, to the center of my document, and then I'm going to move my mouse out, and you see you're generating a rectangle that's based on the center of the document. Now, if you look at the blueprint, we have a base measurement of 50 by 50 millimeters. So I'm going to enter this into these text boxes. I can actually type into the first one just by typing the number. Then I can come back and click on the second text box, or I can just hit my Tab button on my keyboard. And when I hit Tab, you'll see that I jump to the second measurement, so I can go back and forth by tapping on the Tab key on my keyboard. So I'm going to also type 50 millimeters here, and I'm going to hit Enter. When I hit Enter, I have generated a rectangle that has a 50 by 50 millimeter base. So one important thing to note here with sketches is you can exit them at any time. Say if you click Finish Sketch, so where's my drawing? So if you expand on the Sketches menu here, you can actually turn the sketch back onto visible by selecting the small little eye here for visibility. You can actually select stuff and also hit the shortcut V, and you can hide things. Select them, hit V. They will become visible. Anyway, your sketch is here and it's editable. You can always come back to this particular sketch. You can double click this sketch and come back and edit its different measurements and keep working on it. Then you can just click Finish Sketch. If you've accidentally exited a sketch that you were working on, you can also come back, find it in the sketches list, double click it, and you'll be able to re-enter it. Also, the sketches will start piling up here on your timeline. In the bottom, you can see this is the first sketch that we created. It's here in the timeline already. So I can just also double click here on the bottom where the sketch is, and I'll be able to keep working on it. Okay, and you'll see that once you close a drawing in your sketch tab, the center will become this light blue color. That means it's selectable. So I'm going to select this center portion of the rectangle, and I'm going to use this to generate an extrusion. So I am going to go find the Extrusion tool by either going back to my solids tools here and then going into my menu and selecting the Extrude tool, or by just pressing the E key, which is the shortcut for extrude. You'll be using this particular shortcut a lot. So this is usually a very fast way to do it, just by hitting the letter E in your keyboard. Right? So once you hit the letter E, you've now entered the Extrude tool. Let's navigate a bit by using our mouse. So actually, if you hold your Shift key in your keyboard, and then you hold down the scroll wheel on your mouse and move your mouse about, you'll be able to rotate from a orthogonal view into this sort of turntable orbiting around the object that you're creating, and this will let you navigate quite a bit. If you don't hold your Shift key and you just rotate your scroll wheel on your mouse, you'll be able to zoom in and out. And if you hold your scroll wheel, if you click it and then you move your mouse around, you will be able to pan the view. So this combination of the Shift key and your scroll wheel is going to allow you to navigate the interface in different ways. So now that I've rotated the view to be a bit more comfortable, I'm going to then enter here on the Extrude environment that's opened. I'm going to enter a distance. So in this case, I need to have a 5mm thickness for this initial plate that I've generated. So I'm going to enter the number 5. Notice here that operation is a new body. We're not modifying a body since this is the first body on the screen. So the new body is the option that we want for this particular operation. So 5mm, I'm going to click OK. And when I do, I've created the first body on the screen. So if I expand the bodies panel, now I have body number 1. So let's now create the second part of that top object, which is this sort of cylindrical object that sits there. So as I mentioned, you can create sketches either on different origin views, such as the top plane, the side plane, the front plane, but you can also generate a sketch on a surface. Another way to access this is to actually click on the surface, and then I'm going to right click on it, and then I come down here and I can create a new sketch by clicking on the Create Sketch button. I'm going to do Look At. Your view might automatically have moved to Look At the active sketch. And now I'm going to create a circle. So I'm going to go to the Create toolbox. I'm going to find a center diameter circle. And the shortcut's the letter C. I'm also going to snap this to the origin. And in this case, I'm not going to enter a dimension right away. I'm just going to give it whatever size, and I'll show you how to dimension things. So once I've clicked this, if I want to exit the circle tool, I can just tap the Escape key now. See, I'm going to get out of the circle tool. Now, if I drag this circle around, you can see that it doesn't have a defined measurement. So this circle it's not tied to any particular measurement, and you'll see that the line is blue. The blue lines in the sketch will mean that this line is not defined by any dimension. It's not constrained. It's not set by any dimension. So we're going to add a new dimension to constrain this sketch. So I'm going to go to create, and then I'm going to go down to sketch dimension, or I'm going to hit the letter D, shortcut D, on my keyboard. So I get the dimensioning tool, and I'm going to click here on the exterior line of the circle I created. So see, I want to place a dimension here. And in this case, the diameter of this particular circle, I believe, is 40 millimeters. So I will type in 40 and I'll hit the Enter key. Now I've defined that the circle has a diameter of 40 millimeters. And you can see how the line has transformed from a blue line to a black line. I'm going to hit the Escape key to exit the dimensioning tool. And now there's two areas that have been created by this, and Fusion's smart enough to detect that there's a line here that intersects the first surface that I created. So I can select either the inside or the outside area to generate another extrusion, for example. So I can click on the center area. I can tap the letter E for extrusion, or I can also right-click this area and go to Extrude. Or I can tap the letter S on my keyboard as well. Let's see, I'm going to exit this, do it again. Select the area, tap the letter S. I'm going to search for Extrude, and then I'm going to select Extrude from here. So I'm going to extrude the cylindrical section here of my object, which has a height of 30 millimeters. So I'm going to type 30 into this box. And by the way, if you you can actually drag this and just create the height here with this dragging motion. If you actually drag into the object, you'll see that you'll go from adding material to removing material, and you can actually use this to, let's say, puncture a hole into the part, right? I'm going to go back to 30 millimeter height here. You can also type negative numbers and it'll go in the opposite direction. And the operation here, now you have a choice. You can say, I'm going to join this part with the first body that I created, or I can create a whole new body. In this case, we're going to select join because we want to add material to that initial part. Great. So now we've created this cylindrical face here. Let's add this center hole that goes to the entire body. So in this case, I'm going to select this top face here of this part, and I'm going to right click and say create sketch. Again, I'm going to go to an orthogonal view. I click in look at, or it might have happened automatically for you. And I'm going to create a new circle. This time around, I'm going to tap the C key on my keyboard, the C shortcut for circle. And I'm going to place this circle also on the origin. I'm going to snap to the origin. And now I'm going to enter the dimension. And this time for the inner hole, the dimension is 25 millimeters diameter. So now I've generated a circle here. Now, as I said, it'll detect different intersections within the sketch. So I'm going to select the inside area here. And now I'm going to again hit the Extrude tool by either selecting the E key on my keyboard, doing a right click here and going to Extrude, or also you can go to the Solids tool and go to Create and Extrude. You can always go find things here if you don't find them. They're always here in this menu. So if you pull on this arrow, you'll see that you're cutting through the piece. And if you cut far enough, you'll actually cut through this piece. And this is really tempting to say, I'm going to just cut through this part, just pull a long distance and cut through it. But this is not the best practice, because the beauty of parametric modeling, and Fusion 360 is a parametric modeling software, is that at any point in time you can come back and adjust original features that you did. So let's say I can adjust the length of this cylindrical extrusion that I just did and make it really long. And if I make it really long, maybe this perforation is not going to go all the way through now. And you can fix that. You can tell it to actually go not to a specific distance, but you can change the extent to being from a distance to say to object. And then you can select a face in your object, like this bottom face, and by doing that, I'm going to tell this feature to actually cut only to that face. But then if I come back and stretch that cylindrical face to be really long, it's always going to come back and cut all the way down to the bottom face. And that way I make sure that it works no matter how many changes I create. So I'm going to select OK. And now I've created a hole. All right. So now let's go and generate the small screw holes that are on the corners of this piece. We're going to select this top face, and again we're going to start a new sketch here by using either of the options you've been using. I'm going to go and look at this top view, orthogonal view, and now I'm going to create another circle, and this time around I'm not going to snap it to anything. I'm just going to sort of place it around here and not even going to select any kind of measurement. I'm going to hit the escape key to exit the circle tool after that. So now I've created this circle here that is not really tied to anything. It's not defined by any measurement. You can drag it around and you can also stretch it by just pulling on the outer line of it. So now let's add a dimension to actually constrain this circle in place and tell it exactly where it needs to be. So the first dimension that I'm going to enter, and I'm sorry if this is a bit confusing here on your drawing, but I've added a thread to that particular hole, so the dimension's gone down to something like 4.23, but the actual dimension that we're going to enter for this particular circle is going to be 5 millimeters. So I'm going to enter a 5 here. So I've told Fusion360 that this circle is a 5 millimeter diameter circle, and now I'm going to place it in space by using other objects as reference. So again, with my dimensioning tool, which I access with letter D, or by going to the Create menu and choosing Sketch Dimension. I'm going to select the center of the circle, and I'm going to select the outer line of the circle. I'm going to move my mouse upwards. You can see I've started to generate a dimension here, a linear dimension, and I'm going to click here to place it, and it's immediately going to ask me for a value. So I'm going to type in 5 millimeters, which is this distance between the edge and the center of this circle, and I'm going to do that again, but this time around I'm going to select the center, and I'm going to select the top line, the top edge of this plate. I'm going to place this measurement here and also type in 5 millimeters. So by doing this, you can see that the circle has now turned from a blue to a black color. That means that the line is completely defined by these measurements. And now I can come back and do an extrusion. And if I come back and change, let's say, the size of that plate, instead of 50 millimeters, I make it 100 millimeters wide, the holes that I cut are still going to be in the corners of that object, because they're just going to always be 5 millimeters away from the edge of that rectangle. So I can come back and change these measurements in the future. Okay, so now I'm going to select the center of the circle that I've just generated, and again I'm going to do the Extrude tool by tapping the shortcut E, or going to Create Extrude within the Solids tab. And now I'm going to cut through my plate, and again, instead of just dragging this arrow here and cutting through this, which is the easiest way, I'm going to do the proper thing and say the extent of my cut is going to be to object, and I'm going to select the bottom face of this plate, and that way it's going to cut all the way through that bottom plate. I'm going to select OK. Now I've generated a hole in one of the corners, right? So we can repeat the same operation on all 4 corners, or actually do a sketch that has all 4 holes, and we can do a single extrude operation by selecting the multiple areas inside the circles. But I can also use other tools to repeat this hole. So one thing I could do is I could use the mirror tool. So let's try the mirror tool for a second. So one thing you need to be able to access with mirror tool is to be able to select a face or a plane that will be the face or plane about you're mirroring this feature. So I'm going to keep my view here. I'm going to go to the Create menu. I'm going to select Mirror. And then the pattern type, I'm actually going to choose features. So I'm going to actually mirror the entire last operation that I did with my extrude for the hole. So when the next prompt is going to be for you to select the objects which are being copied. So I'm going to go down to my timeline here. And this timeline contains all the operations that you've done in order, and we'll go back to that in a second, since that's one of the more interesting, juicy parts of doing parametric modeling. I'm going to select that last operation that I did, which is the hole. And now I'm going to go to mirror plane and select a plane to do this mirror about. And I'm going to select the plane that sits right here. Now I'm going to get this sort of ghosted preview of the mirror operation that I'm doing. And then I'm going to say OK. Excellent. So I've created another copy, and then I could take, repeat this mirror operation, select both the extrusion and the mirror operation, and use the perpendicular plane to generate a copy that goes on the other side as well. That would be one way to do it. But actually, I'm going to go back here and use a totally different tool to do this. I'm going to create a pattern. So I'm going to go to the Create menu. I'm going to go down to the Pattern tool and choose a circular pattern for one. So again, the pattern type can be either bodies, components, or features. Again, now I'm going to choose feature once more. And I'm going to choose the hole operation here, the last one in my timeline. And now I'm going to go to the axis selector, and I'm going to choose either the center vertical axis, or you can also choose anything that is concentric to what you're trying to do. So cylinders will also work as an axis of revolution for these circular patterns. So I can select this cylindrical tool here as a reference as well. And now you see that I get this little menu here that lets me tell it how many copies should be distributed amongst this circular pattern. So if I say 3 copies, you can see that it's going to try to create equally distant copies around this circular pattern. I'm going to choose 4, and if I choose 4, that'll actually create a hole on each corner. If you had, instead of a square plate, you had a pentagonal frame, you can choose 5 copies, and then these 5 copies will get distributed evenly. So I'm going to say OK. And now I've created the 4 holes that I need for this particular operation. So, okay, so let's talk a little bit about this parametric design thing. Why is it important, and what do I benefit by doing it? So if you look at the bottom part of this interface, you'll see the timeline, and you can actually go and drag this timeline to any particular operation that you've done in the past, and you'll see that the design will revert to how it looked at that particular point in time. So you can go back to your first extrusion, for example, and actually modify it. So if you go and double click on any of these things, you can modify. I'm going to bring this back to the present, if you will. I can go and double click any of these features and go back and modify their different dimensions and settings. For example, I can say, instead of having a 5mm plate, I would like to have an 8 or a 10mm plate. And when I do that, my entire design will change. So because I correctly selected my holes to go all the way to the bottom plate, my holes will still go all the way through. My design has been modified accordingly. My holes are still right in the right place. But if I go back to the initial sketch, and I can either right-click these and do Edit Sketch, or I can just double-click them to open them. This is the first sketch that I did. It has the size of the base plate, 50mm. I can actually go and modify this and say that this is now 75 millimeters in this direction, and maybe 75 millimeters in this other direction. So I'm going to make this plate nice and wide, and if I say Finish Sketch, my base plate has now been modified. But because I referenced the outer edges of my sketch when I dimensioned where the holes were, I've kept this constant, so the holes are still in the right place. So you can come back, and if you've been disciplined and built your object by dimensioning everything appropriately, you can go by and create large modifications to your object and still be able to have a functional object at the end with no errors. So again, you can go back and change these settings if you go back in time, if you will, and modify these objects as you go. So the next thing that I'm going to do is I'm going to fillet these corners. So I'm going to add a radius to some of these corners. So if I now go into the Modify tool panel and I choose Fillet, or the letter F in your keyboard, you'll access the Fillet tool. Now you can select different edges or faces. I'm going to select the corner edges. And I'm also going to select this edge here, which also has a radius in our blueprint. And now I'm going to enter 2.5 millimeters, which is the indicated radius for these parts in the drawing. And as you can see, this has created a fillet operation at 2.5 millimeter. It's rounded off these different edges that I have selected. So I'm going to click OK to do this simple fillet. And of course, the fillet tool has many different options that we'll go back into in a different video. But this is the more basic application for it. The next thing we're going to do is we're going to play a little bit with adding threads to a particular hole. So if you go to the Create menu, you can go find a Thread tool. And Thread will actually let you select any particular cylindrical shape, and it'll add a thread, either a male or female thread, to this particular hole. So once you open the Thread tool, you can select all these holes. You can hold the Control or Command key, depending on if you're on a Mac or a PC, and select multiple things, and a thread will be added to it. So there's two ways to add a thread. If you leave this checkbox that's called Modeled unchecked, then the thread will just be indicated. It's something you can go and indicate in the drawing to specify that this particular hole should be threaded with a particular measurement of thread. Or you can actually model this. If you, for example, trying to 3D print something that'll actually thread together, you can select Modeled, and then the thread will actually be modeled on the part. Now, from these options, you can choose different standard types of thread depending on the type of bolt that you have. If you have a coarse or fine threaded screw, or if you want to actually have a different diameter of hole, you can actually specify it, and it's going to attempt to increase the diameter or decrease it depending on your selection. In this case, we're going to stick with a 5.0 millimeter or M5 hole, and we're actually going to select the modeled checkbox, and we're going to hit OK. And we've created holes that are threaded that are going to accept the threads for the screws that we're trying to use when attaching these two plates. Excellent. So now we've completed the first part in our assembly, and now we want to work on a second part. We could potentially just start working on a brand new body here, but I want to talk to you a little bit about the hierarchy of things here in Fusion 360. So you have bodies here when you start creating this particular object, and when you can choose to start modeling in different ways. You can actually choose to start creating components when you first start your file, and for most people that's actually a more advisable way to start working on things. For this particular exercise, I just wanted to get going with the object right away. And when you actually start modeling without generating any blank components before you do that, you end up with a single component, and this component contains bodies. So you can actually now turn these different bodies into different components, or you can add a blank component. We're actually going to add a blank component to be able to work on our second object or plate. So I'm going to go to Assemble, and I'm going to select New Component, and I'm actually going to say this component is going to be called Plate. I can either select it to be activated or not. I'm going to say Activate this component. I'm going to click OK. And now you see that this object has now turned into an assembly. And now this assembly contains this body, which is a loose body, and then contains a second component that's called plate. And plate is an independent component inside this assembly. The body for the initial part has been grayed out. You can still select it and use it as a reference to build other things. However, it's everything we build inside plate as it is selected is going to stay inside the plate object in the tree. And you'll see how that works in a second. See this little dot here that is selected that looks like a little eyeball? This actually indicates which component is active. So if I want to activate the main assembly, I can go and tap here in the little eyeball, and I'm activating the entire assembly. If I'm going to go back into plate, I can actually activate here plate. One more thing I want to do before we move on is I want to turn this body, the initial body that we used, into another independent component inside this assembly. So I'm going to select this component. You can select any existing geometry. You can go back to Assemble. You can say New Component. And now the checkbox from Bodies will or will not be selected depending on whether you had this object selected or not. I do want to have it selected, and I'm going to click OK. All right. So now I have the plate, which is a blank component, and I have the component that I built initially, which I can always come back and rename. I can name main body, and I can have plate, so I can activate them individually. So now I'm going to go back to activate the plate component, and I'm going to start building this bottom plate. And I can actually now select this bottom face here as a basis for a new sketch. So I'm going to say Create Sketch. I'm going to go to the Look At tool again. And now we're going to actually copy some of this geometry from this bottom plate by using the Project tool. So actually, if you go to Create and then go to Project or Include and to the Project tool, or just using the P shortcut on your keyboard, Project will actually let you choose something like this bottom face, for example. And then by clicking OK, all of these lines will get copied onto your current sketch. So if I now hide main body, as you see that I've copied the lines, but these are still referencing that top part. I can show this again. And now you can use these lines to create other geometry. So now I can see that the large bottom plate is actually 10 millimeters larger. And the way that that was created is I'm now going to use the Offset tool. So I'm going to go to the Sketch Panel Create menu. I'm going to, to the Modify menu. I'm going to select the Offset tool, or I'm going to tap the shortcut O. And I'm going to select this outer line here. And you can see that now I can actually drag this to the inside or outside part and create an offset line. In this case, I want to create a 5 millimeter offset, and this is actually going to create this outer line for the large plate that sits underneath the main body. Right? So now I have these selectable areas here. If I actually hold Command and then click, I can actually select these. And now I can potentially just extrude this, but if you notice, if you look at your drawing, those holes that are in the bottom part are actually clearance holes. That means that they don't have a thread. They're actually a slightly larger measurement. Instead of being 5 millimeter diameter, they're actually 6 millimeter diameter. So I'm going to hit the Escape key. But see, now that you've generated these projected lines, you can actually go and use them as reference. For example, I'm going to select the Circle tool, and I'm going to create a circle here on the center point. And now I'm going to type in 6 to create a 6 millimeter hole instead of a 5 millimeter hole. I'm going to repeat this on all 4 corners. Now if I go and select these areas, you can see when I extrude my new bottom plate, I'm going to create a plate that does have a larger clearance holes for the screws. Alright, so I'm going to go to my Extrude tool by tapping the shortcut E, or going to the Solids menu and then clicking Extrude. And I'm going to create this new plate, and this new plate is going to have a thickness of 5 millimeters, and it's going to create a whole new body. I'm going to tap OK. And you can see this new body is now solid, and it resides not inside the main body component, but it resides inside the plate component. So these are now two separate components, and these components can be mated in space to each other. And this way you can create assemblies, both static and moving assemblies, and we'll go deeper into assemblies in a future video where we're actually going to create assemblies that move around. But for now we're going to create just this static assembly. So now I've created this bottom plate, and it looks like it should. And you can see that I have my top object created. It has the threaded parts. And now what's missing here is to actually come back and insert components for the screws. So I can go ahead and model my screws, or I can actually insert them from a library, which is what I'm going to show you just now. So I'm going to activate the main assembly. I'm going to go hit the little circle here. When I do that, you'll see that all the parts become active. Both the plate and main body components become active. Okay, I'm going to go to the Insert tool, and I'm going to say Insert McMaster Car Component. This will open a small browser window with the McMaster Car website, and you can browse here for through the entire catalog they have. So in our case, we're going to go to the Screws and Bolts section. We're going to open the Socket Head Screws section. You can also type these in the search, by the way, here on top. So Socket Head Screws. We're going to go to the top left part of this menu here. I'm going to select metric because we already know that this is a 5 millimeter bolt, so it's an M5 bolt. So I'm going to select metric here. And now from the thread size drop down, I'm going to select a M5. Oops. Okay, it's a little finicky. M5 screw. It's going to have a 0.8 millimeter pitch because we selected a M5 by 0.8 thread from the thread menu, if you recall. The next thing we're going to define is the length. We're going to choose a screw with a 10 millimeter thread length. You know, both the plates that we created, both the top and bottom plates, are 5 millimeters apiece. So this should be enough to cover the entire thread length that we need. And then we're going to choose a low profile head from the profile menu. When we do that, we get a material choice. That's not very important for now. We're going to just say steel. And we're going to scroll down here on your right panel and go down to the different options that you have. So you have, let's say, a black oxide. You can, if you were choosing material for an assembly here, you would go into choosing the exact alloy that you need for your particular application. But for now, we just want something that is the correct size. So I'm going to scroll to the side here. I'm going to click on this item, and it's going to pop open this small window. I'm going to click here where it says product detail. It has a little cat icon. Now I've opened the individual object that I'm trying to insert. So I'm going to scroll down on this window. You can see the drawings there. And I'm going to download this file. And the way that I do that is I'm going to go to this drop down. And from here I'm going to choose 3D step as my file type. And then I'm going to hit save. As soon as you hit save, Fusion360 is going to download this component from McMaster Car, and it's going to insert it into your assembly. So for now, we're going to keep this screw here. You can rotate it into its correct orientation, sort of. We're going to keep it just here, and now we have the correct type of screw that we want for our assembly. Next step that we're going to take here is we're going to generate an assembly between these parts. So these parts here, if you just drag one of them, you can see that they're not tied to anything in space. They're just sort of floating there. They have no reference to the document other than the place where they are. It's not really defined by anything, and we're going to change that just now. The first thing that we need to do is we need to affix one of the objects in place, in space. So we're going to tell Fusion 360 this particular object in the assembly is not going to move. Now, one important thing is you can only assemble components to each other. So if you just have loose body objects in your document, it's impossible to join them into an assembly. They all need to be components. So if you have a list of bodies, you first need to convert these components by using the new component dialog here on assemble, and then selecting from bodies, selecting such bodies, and each body is going to be turned into an individual component. So I wouldn't suggest doing that as a final step. I would actually suggest creating new components as you build your object, and that'll help you keep things in check and under control in your mind. Okay, so I'm going to select the main body here in my browser, and if I just right click this body, you'll see this option here that says ground. So if I ground this object, and you see that when I do that, you'll get this little push pin icon that is next to the component. Now this body, if I try to drag it, it's not going to move anywhere. It's fixed in space wherever I had it. Wherever you've moved it and you've grounded it, it'll stay there, and everything that you assemble to it will stay attached to this particular object. So if you use a rigid joint between another component and this component, they'll be fused together and unmovable. If you were to use a movable joint, such as a revolute joint, and others, we'll get into those in the next video, then you can create moving assemblies that simulate different mechanisms that you can design. So this is a great way to simulate assemblies of different objects before you actually build them. Okay, so now let's explore the assemble menu here. So if you go to assemble and we say create a joint or an as-built joint or a rigid group, let's read the descriptors. For example, rigid group says it'll lock the relative position of the selected components. So these components will be treated as a single object when moved or when joints are applied. That's an easy shortcut to just weld and fuse two things together. Let's actually select joint. So you're always going to hit capture position here with this warning. So now you have to select two components and two particular points of attachment. So the first thing we're going to do is we're going to select this particular component here. If you actually select one of these faces and then hold your command key, then you will get to choose this center portion here. I'm going to tap here. Then the bottom plate is going to get grayed out and the next object is going to become available. So we're going to choose here. We're just going to hover over this face and then I'm going to hold the command key, and I'm going to choose again the center. So it's going to automatically detect that what I want to do is I want to generate, if I go here into the motion tab, it's going to generate a rigid joint between these two. So it could work in different ways, and if I select different types of joints, it'll try to simulate different things that I could be doing. So if I select a revolute joint, it's going to try to detect that I know, for example, if I selected these two pieces and I selected the center point of attachment between both of them, it's going to think that I'm trying to create some kind of concentric joint. If I say slide, it's going to try to generate something that slides along the concentric axis. Cylindrical is going to create a concentric movement, but that can also slide along a path. But for this one, I'm just going to go and choose a rigid joint. I'm going to click rigid because these two pieces are just going to stick to each other. And I'm going to select OK. So now I've actually fused these two pieces together. If I try to drag these around, it's impossible to move them. All right. Now we're actually going to attach the screws in place to this plate here. So again, I'm going to go to Assemble. I'm going to say create a new joint. The first object that I'm going to choose is the plate. I'm going to hover over this bottom face. I'm going to hold the command key, and that'll let me choose different predetermined attachment points. The one that I want is actually this center point here. And now I'm going to choose this top face here for the screw. I'm going to hold my command key to be able to select the center of this face. When I do that, It's going to actually move these two objects in place to simulate this joint. It's also going to be a rigid joint. It could also be a revolute joint. Let's say if I wanted to create something like a hinge, but I actually do want it to be a rigid joint. I want this screw to stay in place. I'm going to say OK. The objects are going to go back into their place where they should be, and now this particular screw has been assembled in place with the thread where it should be. Fantastic. Okay, now I can go and create copies of this. I can do it the same way that I actually copied the holes. I can go back into the pattern view. I can create a circular pattern. And instead of choosing features, I can actually choose components in this assembly. I can select the screw component, and then I can select the axis of revolution. It can just be this cylinder section here. Again, I'm going to say there's 4 copies of this, and it's going to create a copy in each corner. And you'll see the browser now has 4 copies of the same object. Now, take in mind, these are instances of the same object. You can clearly see that because there's a part number, and then there's a colon, and then there's 1, 2, 3, 4. So if you modify these objects, every copy will be modified in the same way. If you change the material for these objects before rendering, all the copies of the screws will change. Anything that is just a copy of this object is going to have a colon 1, 2, 3, 4, 5, whatever next to it, and it's going to be instances of the same component. Also take into account that anything that you copy along is not going to be the assembly. The joint for this is not going to get copied. So I can see these copies that I've created, I can still drag them around. They're not fixed in place. I still have to assemble these in place. And you can definitely tell that happening because I have this joint there that's visible that is not visible in the others. So I can go back and again do joint. I can also just select the shortcut J to create a joint. So I'm going to tap on J. I'm going to say capture position. I'm going to hold my command key again to select this center point. I'm going to select this face here by hovering over it, holding my command key, and then selecting the center. And then I'll make sure that the type of joint that's being used is a rigid joint. Say OK. Now I've assembled that second screw. Do this again. I can do the opposite too. I can go back and select the screw first, and then the plate second. Now I have 3 out of 4 joints. If I drag this away, this is the last screw that is not actually joined in place. Okay. Now I'm going to hit OK. And now I've actually successfully joined all parts in my assembly. They've all been assembled correctly as noted on your drawing. Fantastic. If you've followed me so far, congratulations. In our next video, we're going to touch on other more advanced options here in the menu and more advanced sketching tools as well. Thank you for following.